Welcome to our exploration of the biomechanics of human skeletal muscle. In this video, we'll uncover how skeletal muscles work together to produce the coordinated movements that allow us to perform everyday activities. From walking and running to lifting and pushing, our muscles play a vital role in every motion. Understanding these mechanisms not only helps in the study of human movement, but also provides valuable insights for athletes, therapists, and anyone interested in health and fitness. Let's begin by looking at the basic functions of skeletal muscles and how they contribute to our ability to move with precision and strength. Muscle contractions are the foundation of movement. There are three primary types of muscle contractions, each defined by how the muscle changes length during activity. First, concentric contractions involve the muscle shortening as it generates force, such as when you lift a weight. Eccentric contractions occur when the muscle lengthens while still under tension, like lowering a dumbbell. Lastly, isometric contractions happen when the muscle remains the same length, holding a position steady without visible movement. Each type plays a unique role in our daily actions and athletic performance. Better understand these contraction types, let's visualize them. Imagine performing a bicep curl. As you lift the weight, your biceps contract concentrically, shortening to raise your forearm. When you lower the weight, the same muscle contracts eccentrically, controlling the descent by lengthening. If you pause and hold the weight midair, your biceps are in an isometric contraction, maintaining tension without changing length. These three modes are essential for smooth, controlled movement and injury prevention. Muscles don't just contract, they also assume specific roles during movement. The main roles are agonist, antagonist, stabilizer, and neutralizer. Each muscle's function depends on the movement being performed and the forces involved. By working together in harmony, these roles ensure our movements are smooth, efficient, and safe. Let's break down each role and see how they contribute to coordinated motion. Agonist, often called the prime mover, is the muscle primarily responsible for generating a specific movement. For example, during elbow flexion, such as when lifting a cup, the biceps brachii acts as the agonist. It contracts to produce the desired motion, leading the action. Without the agonist, movement simply wouldn't happen. This role is crucial in every voluntary action, from simple gestures to complex athletic feats. See the agonist in action. When you perform a bicep curl, your biceps brachii contracts to lift your forearm. This muscle is the driving force behind the movement, working efficiently to overcome resistance. The concept of the agonist is central to understanding how targeted exercises strengthen specific muscles and improve functional movement. Opposing the agonist is the antagonist. This muscle acts to slow down or stop a movement, providing control and balance. For instance, during elbow flexion, the triceps brachii serves as the antagonist, ensuring the movement is smooth and not excessive. The antagonist's role is vital for joint stability and injury prevention, as it helps decelerate the limb and protect against sudden, uncontrolled motion. Imagine lowering a weight after a bicep curl. Here, the triceps brachii contracts to control the descent, acting as the antagonist. This coordinated action between agonist and antagonist muscles ensures that movements are not only powerful but also controlled and safe. The balance between these two roles is essential for efficient and injury-free motion. Stabilizer muscles play a crucial supporting role. They act to stabilize a body part, allowing the agonist to perform its movement effectively. For example, during a push-up, your core muscles stabilize your torso, providing a solid foundation while your chest and triceps move your body. Without stabilizers, movements would be inefficient and potentially harmful, as the body would lack the necessary support. Stabilizers are active in many daily activities, not just exercise. When you stand on one leg, your hip and core muscles stabilize your body to keep you balanced. This role is especially important in sports and rehabilitation, where stability is key to both performance and recovery. Training stabilizer muscles can enhance overall movement quality and reduce the risk of falls or injuries. Neutralizer muscles ensure that movements are precise by canceling out unwanted actions produced by the agonist. For example, the biceps brachii not only flexes the elbow but also causes supination of the forearm. The pronator teres acts as a neutralizer, counteracting the supination to allow pure elbow flexion. This fine-tuning is essential for complex, coordinated movements. Neutralizers are often overlooked but play a vital role in refining our movements. When you grip an object, multiple muscles work together, with neutralizers ensuring that only the intended motion occurs. This coordination allows for smooth, controlled actions, whether you're writing, throwing, or performing a complex sports skill. Without neutralizers, our movements would be less accurate and more prone to error. Recap: muscles can act as agonists, antagonists, stabilizers, or neutralizers depending on the movement and context. The agonist is the main mover, the antagonist controls or opposes the action, the stabilizer provides support, and the neutralizer corrects unwanted movements. This teamwork ensures our bodies move efficiently and safely, adapting to a wide range of activities and challenges. Let's revisit the biceps as an agonist. When you lift your arm, the biceps contracts, acting as the main mover. This example highlights how specific muscles are recruited for targeted actions. Understanding which muscle serves as the agonist in different movements can help design effective training and rehabilitation programs. During the same arm movement, the triceps acts as the antagonist. It lengthens and controls the motion, preventing the arm from moving too quickly or beyond its safe range. This balance between agonist and antagonist is crucial for joint health and coordinated movement, especially in dynamic or high-speed activities. Core muscles often serve as stabilizers, especially during exercises like push-ups or planks. They keep the torso steady, allowing the arms and legs to move efficiently. Strong stabilizers are essential for posture, balance, and injury prevention, making core training a key component of any fitness routine. In performing a bicep curl, the pronator teres acts as a neutralizer, preventing unwanted rotation of the forearm. This ensures that the movement remains focused on elbow flexion. Such coordination between muscles allows for precise, controlled actions in both daily life and athletic performance. Understanding muscle roles is especially important in exercise. Whether lifting weights, running, or practicing yoga, knowing which muscles are acting as agonists, antagonists, stabilizers, or neutralizers can help optimize your workouts and prevent injuries. This knowledge also aids in rehabilitation, ensuring that exercises target the right muscles for recovery and strength. Applying muscle theory in real life can enhance performance and safety. For example, athletes often train both agonist and antagonist muscles to improve balance and power. Therapists use this knowledge to design rehabilitation programs that restore function and prevent re-injury. By understanding how muscles work together, we can move more efficiently and stay healthy. Let's quickly recap the key concepts. Agonists initiate movement, antagonists control it, stabilizers support the body, and neutralizers refine the action. Each role is essential for coordinated, safe, and effective movement. By recognizing these roles, we can better appreciate the complexity and beauty of human motion. Summary: the biomechanics of skeletal muscle reveal a fascinating system of coordination and control. Every movement we make is the result of multiple muscles working together in harmony, each fulfilling a specific role. Whether you're an athlete, a student, or simply curious about how your body works, understanding these principles can help you move better, train smarter, and stay injury-free. Thanks for joining us on this journey into the world of muscle biomechanics.